of equations, believe it or not. System means you're going to have more than one. Here you've got two equations. You always need the same number of equations as variables. So here we've got two variables, x and y, and two equations. So there's a variety of ways to solve equations. One way is substitution. The other is elimination. You can use other approaches as well. We'll just leave it at that for the moment. They will never say, hey, solve this equation by substitution or elimination. You have to decide ahead of time. So when you look at this system here, does anything stand out to you? Is there anything kind of first step that you would take to solve this problem?
I don't know.
So notice that it's solved for y in both equations. It says y equals and y equals. When that's the case, you can set the equations equal. So you can set 2x minus 4 equal to 3x minus 9. And the reason that works is you're really taking, let me actually snip this into another area of the work screen here. You're actually taking like this first part and you're putting it in for the other y. If you will, you're actually replacing the y with that. So setting the equations equal works if it's already solved for, one variable or the other. Okay, and then you would just solve this equation using standard techniques. So you'd subtract 2x from both sides. Got a little more room here. And so you'd have minus 4 equals x minus 9, add 9 to both sides, and you get 5 equals x. Okay. To find the other variable y, you would go back to either equation, whichever one you like. And since they're already solved for y, it doesn't matter which one you choose. You can, you should get the same value, but I'll just choose the first equation. So y equals 2 times 5 minus 4. 10 minus 4 is 6. And so your answer would be 5, 6, or you might see it like x equals 5, y equals 6, something like that.
Okay.
Okay, so let me have you try one here on your own, please, and then we'll move to the next case, which is a little more difficult than this, but we'll talk about that. All right, so go ahead and try solving this and let me know when you come up with your final answer, please.
I got x and y both equal 3.
X and y equal 3. Let me just double check that here on the answer key. Yes, that's correct. Okay, fantastic. So systems, though, I mean, this is where I've got to, kind of be more blunt and say, you're not going to get a question like this, but this is kind of the basis of all the systems. So we're going to work through the more difficult types of questions that you will see when you're working through this. So another type of system that you might see is when they switch the variables. Okay, so see how x and y have been shifted, and they do this. Now, notice in the previous problem you solved for x first because you set the y is equal. They would ask you, for example, for the value of x, because you have to solve for y first and then put it back into the equation to find the other variable. Okay, so you're probably not going to get a question like that, but here's the other type of substitution problem that you might see. Let me clear out some room here. And this is where we sort of say, okay, this is maybe not completely a standardized test question, but you will get some variation on, hey, solve the system. So this time, instead of setting the equations equal, you take this right here and you put it in for y. So you get 2x plus, and then instead of y, all of this that I've circled goes in that position. And then you solve for x in the usual way. Okay, so here though, you can combine like terms, minus 3x plus 6 equals minus 3. Subtract 6 from both sides, so you get minus 9. Divide by minus 3, so x equals 3.
Okay.
And then you would go back and find y. Okay. So let me give you a question where I actually do think like this is kind of something you would see on a standardized test. So let's look at this next one. All right, so here's a new problem, and we'll work through this one together. This time, you're still substituting in for y, but see how there's a minus in front, and this is a really common thing. And so what you have to do is treat that y like it's in parentheses. And this is very important because you see this throughout standardized tests. You have to distribute this negative to both. And you know that, but under stressful situations, standardized tests, you may find that, okay, some of those things you don't remember, aren't as fast on, but you have to distribute it to both. And that will help you with getting the right answer, because if you don't distribute the negative, the wrong answer is usually there on these tests. So again, you'd combine like terms, subtract 3 from both sides, and you get 12x equals minus 12. Divide by 12, so x equals minus 1.
Okay.
So let me have you try one on your own, please, if I can find one. There it is. Try that one. Okay, go ahead and try that one. Let me know when you get your final answer.
Does x equal 1?
Do you have a value for y or just x on that one?
Oh, I just did x.
Okay, go ahead and solve for y also.
Okay.
That is correct. I'm sorry. Did you say 1 or -1?
I said 1.
Okay, I'm sorry. Okay, let me backtrack. That x is not 1. So let's try that one more time here. So this would be 4x minus parentheses 3x minus 2 equals 5, because you're taking this and putting it back in there. And so it becomes 4x minus 3x plus 2 equals 5. So these two combine to make just 1x, or x plus 2 equals 5. Subtract 2 from both sides, and x equals 3. Since I don't
Okay.
see your work, do you see wherever maybe just a sign error or just small?
Yeah.
Okay, fantastic. So go ahead and try to or get the value of y, please, to finish off this question.
Y equals 7.
Yes, that is correct. Let's have you try one more of these. Actually, let's switch it up. We'll go to the other variable because it's the same style of question. If I've got one, I do. This is kind of an interesting one. I guess. Probably spoke. Okay, so let's look at this question here and try to do the same thing. Try to take this right here and you're substituting it in for x. Now notice there's a minus in front.
Mhm.
So you would still treat it like it's like you're distributing it to both here. So go ahead and solve that for y and let me know what you come up with, please.
For Y, I got 2.
Got y equals 2. Let me check that. Yes, y is 2. So go ahead and find x, please.
For X, I got -1.
Yes, that is correct. Okay. So here, you know, like in full disclosure here on like you're doing a problem like this, but and let me even give you another variation on this type of problem here, because I want you to realize like it's never going to be as direct as just solve the system. Okay, it's going to be it's going to be something more like this. It'll say, what is the value of 2x plus 3y? And if you haven't seen a problem like this before, the steps here are you do have to solve the system. And then you have to substitute the values. Substitute into 2x plus 3y. And I guess the point is that you know how to do this. It's when you get a question like where it says, what is the value of 2x plus 3y? Do you then realize, okay, I solved the system and then substitute them in to find the answer. So let's look at this system together. You know that there's elimination. This is a substitution problem, but it will never say, hey, you know, use substitution or elimination. It'll just tell you to solve it or do something with it. So maybe maybe you still want to use substitution, but here you would solve equation 1 for y. Okay, so you would take 6x plus y equals 8, subtract 6x from both sides, and you get y equals minus 6x plus 8. And then you would take that and plug it into this equation here. So it'd be like 3x plus minus 6x plus 8 equals 2. Combine like terms, minus 3x plus 8 equals 2. Subtract 8. Divide by -3. And so you get your x value and plug it back in, to get your y value. Is that all sort of clear?
Yeah.
Okay. All right. So let's do a couple of elimination examples before we go to the other types of problems you'll see. So let me grab a question here. Almost all elimination systems are in standard form. And standard form is ax plus by equals c, where a, b, and c are numbers. A, b, and c are numbers, and you see them twice. Okay, so when you think about the elimination method from previous classes, you either multiply one equation by a number or both equations by a number.
Mm-hmm.
Do you remember the various cases or how you decide whether you multiply one equation or both equations?
I don't remember.
Okay, so when you look at the numbers 2 and 3, minus 7 and 14, what should jump out at you is that minus 7 and plus 14, 14 is a multiple of 7. 3
Mhm.
is not a multiple of 2. And what that means is you want to do something with this first equation to get that minus 7 to become minus 14y. Well, how do you do that? You multiply by everything by 2. So 4x minus 14y equals minus 86. And then you write the other equation below it. And notice when you add these, what happens when you add them? Well, this goes away. So you get the 7x equals minus 28, divide by 7, so x equals minus 4.
Okay.
To solve for y, well, you got to choose one equation or the other. Sometimes there's one that's better than the other. I don't really know if there is in this case, so I'm just going to go back to the first equation. You put that minus 4 in for x, 2 times minus 4, minus 7y equals minus 43. Minus 8 minus 7y equals minus 43. Add 8 to both sides, and you get 35 minus 35, divide by minus 7, so y equals 5. Is that okay so far? We're
Yeah.
gonna look at more. We're gonna look at more. I'm not gonna ask you to do any on your own yet. But this is the kind of systems problems you might see. All right. So in this problem, it would say solve or do something with the answers, but we need to solve the system. And so what you want to look at are the coefficients. And you're first trying to figure out, well, is like one a multiple of the other? Or does one kind of look like the multiple of the other? Try not to focus too much on the right-hand side. It could be distracting, but what do you see? Is 5 a multiple of 2? Is 18 a multiple of 9?
18 and 9.
Yeah, 18 is a multiple of 9, which means that we really want to do something with that second equation. We want to get it up And even, and I didn't point this out in the first example, you really want them to be opposite in sign. You know, one's minus, one's positive. That really helps you here. So if you multiply the second equation by 2, again, that gives you minus 4x plus 18y equals 32. And then bring this down here, minus 5x minus 18y equals minus 41. So now when you add them, you generally are always adding. The y's go away, and x equals 1. Now, which equation do you think you should use to solve for y, or do you have a preference here? Like, does one stand out to you as being better than the other?
Maybe the second one.
Sure. Yeah. So we can do that. It should give you the same answer, but you just got to be careful there. So putting 1 in for x, you get minus 2 plus 9y equals 16. Add 2 to both sides. 9y equals 18. So y equals 2. All right. So I'd like you to try solving this one on your own. It's the same type of problem we've been doing. It's just that it's different numbers. So go ahead and take a minute or two and see if you can solve that, and let me know when you're all done.
For W, I got 3, and for X, I got 6.
W is 3 and x is 6. All right. That sounds right. Let me check it here just to make sure. And that is correct. Okay. All right. So that's the first type of system that we're going to do here. Actually, I do want to actually get some questions, SAT prep questions in today. So I'm going to go back to what's considered like the heart of algebra here, and we'll look at some questions together that kind of are based on what we just talked about. So we'll come back to systems if we have some time here at the end. I want to make sure we get some of these in today. So here's your, here's your SAT prep question. They give you a system. I say if 2x plus 18 equals minus 12y and y over 2 equals minus 2, what is the value of x minus y? So as a reminder, they're giving you a system because there's literally two equations. There's equation 1 and there's equation 2. They don't have to be the same complexity, although, sometimes you do see them in a standard form. And like I mentioned before, they're not just going to ask you for the value of X or the value of Y. They're always going to ask you for something else. In this case, they want you to take the two answers and subtract them. Okay, so if we were to put this in a more, I don't know, standard format, the system, it somewhat resembles the substitution systems because it's almost like Y has been solved for, but not quite.
Mhm.
Okay, so if we were to solve this first equation for Y, how do you solve it for Y? How do you undo this right here? How do you get Y by itself? I'm asking you.
You multiply by 2.
By 2. So you get Y is -4. And believe it or not, this is an equation. Like this is an equation, even though it's solved, it is an equation. Okay. So this value for Y has to go back into the other equation. So you take that number you just found, you put it back into the other equation, -2x plus 18 equals -12 times -4. -2x plus 18 equals 48. And now you have another equation to solve. Subtract 18 from both sides. -2x equals 30. Divide both sides by -2, and x equals -15. But again, that's not the answer, and neither is -4. And so with this, with standardized test questions, you have to say, okay, I got to do more than just solve it with the skills that I have. So x is -15, y is -4. So the correct answer is D, -11.
Okay.
So they truly are giving you a system. They're truly, but one of the equations is easier than the other. But you have to realize, okay, it's not just about solving the system. I got to take the answers from the system and then do something with them. And that's the challenge of these questions is there's always a synthesis of concepts. So again, let's look at a question here. It's very similar. All I've done is change the numbers. It's a different equation. Okay. If -11x minus 18 equals -9y, and y divided by 4 equals -5, what is the value of x minus y? Okay. So again, you really want to focus on the second equation. You want to solve it for y. So y over 4 equals -5. Clear the fraction by multiplying both sides by 4. Y equals -20. And if you don't see your answer there, that could also be concerned because you might think, oh, I've got the answer. No. You've got an intermediate step. They could put -20 as one of the answers. Hopefully they don't. And then you take that number and put it back into the other equation. So -11x minus 18 equals -9 times -20. That's 180. So you're going to add 18 to both sides. And then you divide both sides by -11. You might think, you need a calculator here. You could argue that you do or don't. 20 times 11 is 220, and 198 is 22 less. So that's 2 11s less, which means it would make it, I'm sorry, it's 18 11s, so that the answer for x is -18. And that could be your hardest part here. So if you're working on these on your own, I mean, grab a calculator if you need to, but know that it's right on the edge of whether you can do it by hand or not. So minus 18 minus a minus 20. Okay, minus 18 plus 20 is minus 2, which is not, I'm sorry, it's positive 2. It's like, why isn't it there? There it is. All right. So if you see the pattern here, how to do this problem, I'd like you to try one or two on your own. I'll put one up for you to look at. All right, let me know when you get your final answer on this one, please.
Okay.
How are you doing on this one?
I got B24.
B24. That is correct. Very good. What did you find easy or difficult about this question?
I don't know. I think it's pretty straightforward once you break it down, know what you're doing, and know to plug it back in.
Yeah, so you know how to do all the steps in this
Yeah.
particular problem. Okay. Here is the next thing that I can do to sort of increase the difficulty when we look at a problem like this, which is to make it free response. Okay, because there's that comfort in like, okay, I have the answers. If mine matches one of the answers, I feel good about it. But there's free response. And let's do one more here. Let me have you try this one here. And if you could do it without the answers and see what you come up with, please. How are you doing on this one?
Okay, I got -19.
So I can hear it. Maybe you hear it. Is there's some uncertainty in your voice, and it's because
Yeah.
the answers aren't there. Whereas, and let me. Ooh, why did that happen here? Let me actually pull up the question with the answers, and then you can see where did that go? There it is. Well, yeah. Give me just a moment here. 5. So here's the question with the answers, and there's your answer.
Oh, okay.
So I like this approach, and it's hard to do as a student when you've got the answers there. But if you cover them up, and so in the practice test that you got, I know we haven't gotten a lot into them, but if there are some at the end that don't have multiple choice, and that's
Mhm.
that's where you got to trust that the steps you've taken and are good, and you just move on, because you don't want to dwell on like, did I get them all, or everything like that. So all right, now
Yeah.
in the time we have remaining here, let's go back and do a couple of more elimination problems just to get a feel for the other type of elimination that you might see. So we talked about how you multiply one equation or the other. The most general case is when you actually have to multiply both equations. And the reason you do that is because neither of the coefficients are multiples of the other. There's no like obvious thing where it's like, oh, the 9 goes into 18, or 6 goes into 24. Here you have to multiply both equations by the other. Now, when you get a problem like this, sometimes there's some help here. They actually, this 2 is the number to multiply the second equation by. I'm sorry, first equation, and this 3, not the negative, is the number to multiply the second equation by. And the reason is because they're already opposite in sign. Do you see that?
Mhm.
Because you always want to add. Okay. So we'll just work on this together. Minus 16y minus 6z equals minus 10. You got to multiply everything by it. That's one of the things that you'll see on these standardized tests. They give you so many things that if you don't multiply the last one, all of a sudden, it doesn't work out here. So plus 6z minus 27, and you tend to want to add the equations. It's rare when you want to subtract them. You're almost always adding here. So that's so this goes away. Minus 37y equals minus 37, and look at that, y equals 1. So sometimes you do get nice answers.
Okay.
All right. So then which equation do you want to use to solve for z? The first equation or the second equation? Do either of them stand out to you?
Probably the second one.
So there's a slight preference for the second one because it's got a positive number in front. And if you see anything like that, trust your intuition and just go with it.
Okay.
So you add 7 to both sides and you get -2, and then so z equals -1. So the answers actually work out really nice in a lot of cases. I don't want to say like as a blanket statement, like you should always look for nice answers, but you should not be looking for weird answers in general.
Okay.
So I think I've said this before. I looked at some standardized test prep materials, and the general consensus is that almost every question can be done without a calculator, even on the calculator sections.
Okay.
So I take that to mean like you should use that to help you. The answer should be nice. But if the final equation was, well, what is 2z plus y? Well, it's 2 times -1 plus 1. You still get a nice answer. Okay. So sometimes even when they have this extra step, you still get something that is useful. All right, so we'll pick up here on Wednesday. We can do some more systems. I got some other systems, standardized test prep questions we can look at. I'll also email you a link to some worksheets to do in the meantime if you've got time. But
Yeah.
that does take us to the end of our lesson for today. Thank you so much, and I'll see you Wednesday.
Yeah. Thank you so much.
All right, bye now.
Bye.